Assalamualaikum warahmatullahi wabarakatuh. Now, we are going to learn about application of differentiation. Now, I would like to call out our team members. First of all, Muhammad Abid Irfan bin Muhammad Shamli. The second member is Muhammad Asrie Muiz bin Muhammad Kusairi. The third member is Muhammad Hafidz bin Muhammad Ridza. And the last one is Muhammad Saiful Izham bin Samsuddin. Now, I would like to call out the title of the selected topic that we are going to learn today. First of all, introduction of application of differentiation. What is applied maximum and minimum? Why we use applied maximum and minimum? Next, introduction of application of differentiation. Calculus, differentiation and integration was developed to improve this understanding. Differentiation and integration can help us solve many types of real-world problems. We use the derivatives to determine the maximum and minimum values of particular functions. Example, cost, strength, amount of material used in a building, profit, loss, etc. Derivatives are in many engineering and science problems, especially when modeling the behavior of moving objects.
So we are moving on to the exact definition is about what is apply maximum and minimum. Apply maximum and minimum is the process of finding maximum or minimum values is called optimization. We are trying to do things like maximize the profit in a company or minimize the cost, or find the least amount of material to make a particular object. These are very important in the world of industry. In calculus, apply maximum and minimum are used to calculate the highest and lowest point of the curve in a graph or to know its turning point. Why we use apply maximum and minimum? This problem is focusing on optimization problems, which is apply maximum and minimum values help us solve optimization problems. These problems involve maximizing or minimizing certain quantities. What we can conclude as an example is maximizing profits, minimizing costs, and finding the least amount of material needed for a specific object. And the last one is determining the maximum height a rocket can reach. What we can have after we learning the apply maximum and minimum. Apply maximum and minimum can help us to enhance our knowledge regarding the use of differentiation. Second, it can help us to comprehend practical maximum and minimum issues. And the last one is to be able to use the appreciate formula to solve the question.
Next is problem statement. Question: a farmer has 1,200 meter of fencing and want to fence off a rectangular field that borders a straight river. He needs no fence along the river. What are dimensions of the field that has the largest area? So the solution is we assume as x is length and y equal to width. As x as a formula constant. X plus 2y equal to 1,200. Sorry for my mistake. So x equal to 1,200 minus 2y. Substitute of x area formula. Area equal to xy. So we get
1200 minus 2y multiply with y, and we get 1200y minus 2y power of 2. From this, we use first derivative of a respect to y and get 1200 minus 4y, and we find the value of y and get 300 meter. This represent to y length. Next, substitute of x equal to 300 meters to x equal to 1200 minus 2y. So x equal 1200 minus 2 multiply with 300 and get 600 meter, represent to x length. In certain question, second derivative are needed to determine the value is either maximum or minimum. So second derivative test must be applied to determine the value. If the second derivative have the value greater than 0, means the value is minimum. If we get the second derivative value is lower than 0, means the value is maximum.
Consequently, determining the proper formula and completing the first and second derivatives accurately will result in a solid answer, a maximum or a minimum cost. That is all from us. Thank you.